Connecting to cloud server. Am I recording? Oh, yeah, it is. So this is a rectangle. Okay, the two terminals should be at the top. With the current balance hit, the rubber band goes on the bottom of the solenoid. Probably should put it down. Place it at the bottom and rest it like this. So what's going to happen is that the current balance here, one will have a sharp pointy part with a slider, and the other part is nothing. So the nothing part goes into the current balance, into the solenoid, and the levers will rest onto the pins. Okay. Actually, I'll do it the other way, right? Because the rests over here would be better if they were on top than below. It's a little bit more stable there than the other side, and you want to create it in such a way whereby it is as stable as you can. We will be putting weights onto the sharp pointy end, right? So if it's bent the other way, just gently, really gently, just kind of adjust it to be able to hold stuff. It doesn't need to be a hook, it just needs to be angled a little bit. Okay, so if you put that in there, what's going to happen is we will pass a current through the current balance using these terminals by making contacts on the pins. So if I put this to the positive terminal, the positive terminal will connect to this pin. It'll touch on the current balance. You can see that there is a line that is actually a wire. So it'll go through, across, and out to this pin, which is in contact with the black terminal, which will go to the power source. So there will be a current passing through here, right, in a U shape. When we pass current through the solenoid, a field will be generated either this way or that way. Don't know which way, some way. Okay, depending on where the coils are rotating clockwise or counterclockwise. What do we want? We want to make use of our Lorentz force. F is equals to BIL. B, I, F. The L is going to be the length of this section here. So you will need to find out the length of this section. Why? Because the field is going to be this way. Field, the current is either going to be this side or that side. We want, because this is a balance, it's like playing seesaw, we want the force to be down. Does that make sense? So when the force is down, this thing is going to go up. Right? The force inside will go push down. This lever will go up. You will then make use of weights to put it on there to try and balance it. Then whatever masses that I put there multiplied by G is going to be the force that is on the inside. Does that make sense? Balance, that's why current balance. So the force pushes down. We add weights on the other end to balance it. We will take the weights that we use to put it on the sensitive balance, electronic balance over there to measure how many grams of mass you have used. Then we multiply that by G to find out the force. Okay. So F is equals to BIL is equals to mg.
Which
9.81, always. You want to use another G? All okay so far? Your understanding is?
I guess so.
I guess so. Okay, very good. So then, as you see, you've got two, one for the solenoid, the other one for the current balance. All right, one for the solenoid, one for the current balance. The solenoid will be the one which is connected to the power supply, which we will adjust to change the magnetic field. We will change the magnetic field. We will measure the force, change the magnetic field, measure the force, change magnetic field, measure the force, and then we will plot a graph of B versus IS. Right? Magnetic field that we've got from the equation. What equation? When we do, why is it not doing anything? Idiot. Of all days, seriously. Oh my day. Ah, there we go. So basically, we're using F to G will be equals to F from your Lorentz force. Yes? So that means our mg is going to be equals to B I L. The I here is from the current balance, not the solenoid. Correct? When you BIL the thing, the I is from the current balance, not the solenoid. When you do this, BIL, the I comes from the current balance. I said it 3 times now. Okay? If you see the recording later, you can hear it another million times. So over here, we will use that to figure out our B, which is going to be mg divided by IC and L. Or rather, if you want, LC is also fine. Length of the current balance. Which part? Just the part that is perpendicular. Because this side, which is parallel, don't matter. The small section, that section that's inside here. Because it's perpendicular to the view. Okay? So it is there. So that's going to be the B. Okay? Then you plot it versus IS. Right? Based on the relationship that's here. When you plot it versus IS, the gradient of that graph is going to be the constant mu naught n over LS. Mu naught we know, n we know, LS, length of the solenoid, we measure. So the gradient of the graph that we get when we do B versus IS should be equal to this calculated value, mu naught n over LS. If it is, then we have shown that the magnetic field follows this relationship.
Wait, then why do we really have the B is
Because you can't find out the B without calculating the force. Think about it. So we're going to set up the circuits. We've got this setup. This is the integration part. If you don't want to get confused, separate it. Rheostat goes together with the current balance. Let's trace it. Power supply, power supply. Okay, so first one is the one up there, power pack 1. Power pack 1. Plug it in. Now, however you found your equipment, please have the courtesy of putting it back exactly how you found it. Okay, good. Just like how your mother says, whenever you do something, put it back in the same place. That way you can still find it.
Know what you said?
Sorry? Well, I said it too, yes, of course. Because I have the same understanding in the house as well. Everything has its own place. The more disorganized you are, the less efficient you are, the more time you waste, the less time you have. So power pack 1 goes into ammeter. Ammeter, there, stab. No, wrong one. Oh, no, yeah, correct one. Right one. There. Oh. From the common, goes into the solenoid. There. And from the other end of the solenoid, back into the power supply. Here. Okay. Setup 1. Power supply, go down to 0, as in 2. Always go from 0. We will be using, now because we'll be passing through currents of significant values, use the 10 amp ones. So setup will be like this with the whole in the middle. Okay. That goes directly to the red part and leave it. Next one, power supply, connect it. That. Follow. Power pack 2 goes to ammeter. We will be using DC, so always DC. Goes to 10 amp at the top. Common from the bottom goes into the rheostat. Rheostat, this time we'll use it variable, but we'll use it variable because we need to control it such that the current inside the current balance is going to remain constant at 2 amperes. Is it 2 amperes? 2 amperes. Stab from one end and the other end, it comes out. Doesn't matter what color it is. Stab it. Okay. Always start from maximum resistance. How you know it's maximum resistance? From one end to try and go to the other end, it must go through the whole section. If you see it like this, means it's following the top shortcut, exit, no resistance, maximum. From here, it goes to the current balance, to the red, follows in, comes out, the black, like this. And from the current balance, it goes back to the power pack. So that goes back to here. Me, personally, I don't like it doing this. So I will turn to let it face me. And in doing so, the cable goes around that side. So what do? Cable goes underneath. No interference, relatively. Okay, leave all of that rubbish behind. That faces you. Current balance goes in, rest. Okay. First, we'll set up the current balance circuit to try and make it 2 amperes. Ammeter needs to be on, if not, there will be no current flow. This one says that there is a battery problem, means Duke will help me get a new multimeter. It's yellow. There we go. Thank you. Remove, put it aside because we have plenty. So that's fine. That it back as it was. This one is black. Go to black. Great. Voltage goes down. Switch on, great, 0.12. Boost, 10 volts. Still not enough, resistance too high, reduce that until you get about 2. Don't go anywhere past 2 because the current balance will get too hot and the solder will melt. This has happened before. We used to have a soldering iron where I fixed it, but I don't know where it is anymore, so please don't. I don't have one at home either. I used to, but I threw it away long time ago. Okay, so if it doesn't, and you need a small adjustment, just tap the thing backwards a little. Because why? The contacts are. So just. If it's about there, if you can't get it anymore, 1.99, 1.99 is fine. All you have to do is later on just record it as IC is 1.99, or in this case, it's fluctuating. So it's never really the same. 1.98, 1.95, 1.98, 1. Blah, 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 blah. So try and keep it as close as possible. That's fine. Once that's set, turn it off. You don't want it to get too hot because you're not done with this. Okay. For your solenoid, very simple. Don't need to do anything, just need to know that it works. Switch it on, turn on the power. You'll see a current. This is your IS. That is your IC. Your IS, what you will do is that you will change the voltage on the power supply. It has 6 settings. You have 6 values. So we will change magnetic field 6 times. So you can't see it, but magnetic field is there, right? So then you change it. There. So this one, it says V use 4. Set the voltage across the solenoid at 4. This is point number 2. So set it at 4. Use that value. I think I remember because, yeah, I made amendments because 2 volts for this magnetic field too small. The amount of mass cannot be detected. Start from 4. Yes, so start from 4, then later on change to 6, and 12. 10, and 12. Technically, if you want to do an 8 as well, that's up to you. That's fine. Okay, so now that that's set, close that, all off, start from scratch. What do you need to do? In order for you, oh, actually, fantastic. In order for you to start, you have to make sure that that thing is balanced first. So the black slider there is for you to balance it. Luckily for me, it's already balanced. So if it's not balanced, so let's say, for example, it's like this. Yes? Then you'll need to adjust it. So the slider is to make sure that it is balanced. Once it's not touching anywhere inside the solenoid, we'll take it as balanced. Because with the ventilation and everything, that's going to cause this thing to fluctuate. If you don't realize that, that is an uncertainty. Some of you paying attention. So once it's balanced, not touching anything, you're set to go. Okay? Turn on the current balance. Check that it's 2. Turn on the field. Watch it move. Where has it gone? It's gone down. Is that what we want? No. We want this one to go up so that we can add weight. If it is not working, what do? Switch the terminals.
Going up and down.
Why do you switch the terminals? Because switching this is too difficult. So just do that from the source. You don't touch anything. Once you're set, don't touch anything. Okay, this is a very tedious experiment. Tedious. It's not difficult. Tedious. Okay. So now, once again, check, 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 check. Goes up. Great. Touching the inside? Yes. Now what? Inside this container, you will see small metal rings for masses. You pour them out. Don't drop them onto the floor because that and a gray floor don't go together. Good luck finding it after. Okay? So take one, maybe smaller one, maybe bigger one. Who knows? Just take one. Right? Maybe this one. And then very carefully put it on the hook. All right. If it's balanced, lucky me. Right? Maybe not so lucky for you, but I don't know, right? So once it's balanced, great. Record. Record. Note that once I swap this around, this ammeter will show negative sign. Does it matter?
No.
No, just take the magnitude.
Yeah.
Okay, because we swapped the terminals around. That's all. Fine. So 1.16, 2.05, balance. Great. Turn it off. What do? You take that mass. Take that mass out. Go over here. Sensitive electronic balance. Turn it on. Let's start. That's pretty strong. So take that. Put it down. In the middle. Close it. 0.040 grams. 1 grams. Good. Record. That is your M. Okay, done. Take it out. Let other people use it because we only have one. What? You don't need that much. Most of the time will be spent here trying to fix it. Once that's done, put that down. Voltage 6. Make sure it's balanced. Start. Redo. Balance. Take the mass. Bring over there. Measure. Come back. Add voltage. Make sure it's balanced. Start. Balance it again. Measure. Redo. So you will get 4 values of. You will get 4 values of B, 4 values of IS. You will then plot B versus IS to get your gradient, which should be the constant there. Or rather the constant. Proportionality, yes, there. Mu naught n over LS. Percentage error, compare it with that. All clear? Think so? Good. Yes. Good. Any questions? Just one what? Well, just pick one mass. Yes. Oh, yes. I forgot the most important bit. If you can't get it to balance, because all of these masses are either too big or too small, may I introduce you to let me introduce you to the wonderful cotton thread. If you can't get it to balance, take some thread. Current in the solenoid. So remember when I told you put it out this way? So you can take some thread. That. And hang it.
What?
Yeah, see?
Oh, what's the point of the third?
Because it's small and light, and sometimes this one a little bit too much, sometimes that a little bit too small, then you take that and you go, here we go. How do you cut it? Did you not just see it? Take that, wrap it around your finger. Cool.
It's like the formula.
Have you not done this before? You haven't done any sewing before? Oh, and you lucky fella. Then you break it. And see, it's already moving, right? So then you just do that. And then later on, you take that masses, bring it to the electronic balance. If you want to, you can roll it into a ball and put it down. Wow. Ventilation might affect the balance, but it's covered. So minor. Okay, all good?
Yes.
Good. Carry on, please.
Okay, time to take a picture.
Huh? You want to take the whole card?
Yeah.
We don't have time.
Oh, this is the one for the.
Well, actually, if you want, we'll push it to the end. So middle, push it to the middle. Just ask Jonathan to get out.
I was never expecting that.
Jonathan.
But I had no idea what this is.
Sir.
Yeah.
Sir. Sir. If you need help setting up, feel free to ask.
This one is
Okay, guys.
S is for solenoid. Is it connected to the solenoid? No. The answer is no. What?
This the bedrooms.
Current balance count. Why are you doing it endo? It's supposed to do B. And we measure. We want to come to this.
Why?
I don't know. I just only have these.
Again.
Man.
Over. LC, LC.
It's growing the better.
And meter over here.
This is excellent.
And meter is here. IC, IS. Oh, I see. IC for the power balance. IS for the solar.
So you don't have to.
Measure this right. You get it?
What about?
We still can calculate it.
Oh, because we need to find an actual.
Yes. Yes.
Okay.
Find the number. Big difference.
There we go. Oh, yeah.
Might not understand, but my.
I'm not sure. Losing the details.
There
you go, between that. I did.
English A2. That means it's six. All you need is you need 7. Go with you. That's fine. So yeah. We want this to be 2. 6 and 2, roughly 2, about 2. That one changes the voltage. Change the magnetic field inside the solenoid. It's stated. Will you not pay attention?
The ramp up there, right?
So what, you get it. Yeah, on top. Help the word on top for a very long time.
Yeah, be fine lah, still get lah.
You guys might need rulers, I don't know.
15 cm? Yeah. Or is it 0.15 meters? So we get the B and the current is not variable now.
Don't worry about it.
I think I want to leave off. No way. Maybe we can stop doing.
When you say you take anything for ready for daily apparatus.
Well, we take from the PDF, we can.
Yeah, when it is so long maybe.
Huh?
Yeah, but you very easy.
Yeah, I wear it. I thought I thought already. Yeah, I mean, woke up today or woke up
9:40.
That's what all your time is not 10:05.
9:40, the luxury.
Okay.
When you live in the city, that's all.
But it's second on your 1 hour or so.
Move on.
Go down and buy the cereal, come up. I got the college.
Yeah. You know what central there?
Upload from Cambridge. Okay. From the.
Okay. Queensberry.
Closer than.
Closer than.
It's just like. You walk to Victoria Mall.
Queen Street lah, is it? Queen Street? Oh yeah.
So between.
Okay. Please don't be afraid to ask for help.
You got on the floor, yeah. Where is this? This is that photo. Yeah. Can find one. Environment you are on. Can find it out. That is. There. Error. Safety consideration. Okay, how it is not. Okay, so yeah,
You know what they say?
exactly.
Don't listen.
Kailangan ka Wait, Oh, no, this one. No, he doesn't do that.